Thank you so much, Tom, for the introduction. I'm really happy to present today, and I will present the results of my research. So I am a recent graduate, a PhD graduate from the Royal Institute of Technology, KTH. And I have been working during my PhD, I've been working at the ITRL, which is the Integrated Transport Research Lab. But before going into my research, I wanted to tell a little bit about myself. So starting with my background, I come from Torino in Italy, and I have a I come from a little small village in the Alps, and I have been uh, I've been keen on sports since I was a kid. And when I moved to Sweden, I then started to do a little bit more cycling. I've been part of Team Rinkeby for 2 years, last year and the year before. And I really like it in Sweden right now. And my journey in terms of studies. So I started with a passion for sustainability, but also engineering. And I started with a bachelor in energy engineering in Italy. And then I have a master's in energy for smart cities. And after doing this journey in energy, I then started a PhD in transport, as I said, at the Integrated Transport Research Lab. And this is what I will talk about today. So my PhD is in on the impacts of innovations and policies on sustainability within the context of road freight transport. And ITRL is the Integrated Transport Research Lab. We do a lot of research in transport and sustainability. And the Integrated Transport Research Lab is a lab that is part of KTH in Stockholm. So a little bit of an agenda for today. I will start with introducing my research. Why is it important? And then I will go into the research goal and questions. And because these research goal and question are very broad, I will describe the 4 cases that I have studied during my PhD. And then I will end with some discussion and conclusion. So to introduce, as I said, like, why is it important? Well, looking at road freight transport systems, they have a lot of benefits, of course, for society as a whole, but they also have drawbacks, especially in terms of sustainability. So when we talk about these type of systems, we often say that a sustainability transition is required. And to do this, I believe that we need holistic methodologies where we include the perspective of different stakeholders and different aspects of sustainability, not just the environment. And one way of doing this holistic assessment is to see road freight transport systems both as socio-technical systems and as complex dynamic systems. And as a little bit of an introduction as how do we see it in terms of also previous literature? Well, as I mentioned, socio-technical systems is one way to look at road freight transport systems. And when we talk about socio-technical systems, we talk about systems where there is an interplay between social and technical aspects. And if we look at the transport system, we can see that there is a combination of what we see like as a more physical and technical components, for example, the vehicles, the infrastructure, and so on, but also social components, where we have people that are interacting with the system, for example, the drivers, but also the receivers of the goods, and, for example, the policymakers that need to regulate these systems. But as I mentioned before as well, I've been seeing these type of systems not just as socio-technical systems, but also as complex dynamic systems. And with complex dynamic systems, we mean a system that have some dynamic development over time. And that's kind of what we focus on when we study these systems. And also we look at feedback and rebound effects, such as, for example, if we think about transport, the impact of a variation of cost in demand or or other feedback like that. And then we also look at accumulation and delays. For example, if we think about the infrastructure again, the time it takes to build the infrastructure, and these types of delays are important to be considered. Um, and then we can see that there is some overlap between these two kind of definitions because when we talk about complex dynamic systems, we see that there is often a diversity of actors and stakeholders, and also that especially in such big complex systems such as the transport system, the policy setting is very important. So to study these systems, different system levels need to be considered because we want to try to achieve a more holistic perspective on sustainability. So what I have done during my PhD is to use a system thinking lens. And now I would like to just introduce what we mean by system thinking and how can we use it in transport. So um, when we apply system thinking, instead of looking at one single element, we look at the element as part of the system, and we're interested in understanding the interconnections between the elements in the system and how these interconnections and causalities between the elements actually bring a system function. So system thinking can enable to understand both the structure but also the dynamics of complex systems such as the transport system. And during my PhD, I have used a system dynamic approach. And the system dynamic approach gives a tool to move from a systems understanding that can be achieved through system thinking to a system representation. So we can build actually formal models to represent systems. And because it's a method rooted in system thinking, but also control theory, it allows to create both conceptual qualitative models, but also mathematical models. So keeping these in mind and given this context of sustainability transition that I try to introduce so far, and keeping in mind that we want to achieve a holistic perspective through system thinking, within this context, I tried to understand the impacts of both transport concepts. And by transport concepts, I mean, for example, business models, but also innovation and how these impact this sustainability transition. But also what I call transport policies. That could be policies, regulation, but could also be something that influences the system, such as culture and behavior. So the goal of my PhD thesis and my PhD work was to understand the impacts of both transport concepts and the transport policies on the sustainability of road freight transport systems. And I really realized during the work that we need to consider also the impact of the transition itself on both concepts and policies, and the impact of policies on the development of the concepts. So I studied the transport systems, having in mind these feedbacks and impacts between concepts, policies, and the sustainability transition. But this research goal is very, very broad. So I try to narrow it down, looking at specific questions. First, I try to understand a little bit more like how can we build a framework to assess sustainability, considering perspective of different stakeholders. And then how can we model using system dynamics, the dynamic complexity of these systems. And after trying to answer these first two questions, which are mostly theoretical and methodological, I then use the frameworks and models created by answering these first two questions to answer the third question, which is more related to the goal. What are the system level impacts of concepts and policies? But these questions are still relatively broad, and to concretize them, I decided to focus on four cases, and those four cases guided me throughout my research. So my PhD actually I started in June 2020, so it was in the middle of COVID. So the first case that I studied is of course COVID, and here the idea was to understand the impacts of the regulations that were in place due to COVID on the behavior of people, and how do these regulations also impact sustainability, sort of through changing the behavior of people. And this has been seen sort of as a policy. So if we go back to this kind of context that I tried to explain before. Then I started looking into the sustainability impacts of different concepts, and I call these urban concepts. And the concepts that I studied are many, but also specifically electric trucks consolidation are the ones that I studied the most. And these are exactly transport concepts that in this framework are impacting the sustainability transition. And after sort of in the beginning, I tried to understand in general how these concepts impact the transition and how can we study these sustainability impacts. But then I delved a little bit into more detail in the City Hub case because especially because of the project that I was involved in. So I studied consolidation specifically. And then in this case, I also try to understand the impacts of different policies. And in Stockholm, there was an idea of having a policy that is an environmental zone. So I tried to understand what would be the impact of an environmental zone on this type of concept. And then finally, I studied the impact of the adoption of electric trucks on the efficiency of the system, and how does this again sort of relate to sustainability. And within this case, I also studied the impact of one specific policy, which is for example, carbon tax on diesel fuel, for example. But we will go into more detail into all of these cases. So now I will start from the first case, which is the COVID case, and you can sort of keep track of where we are in the presentation on the top right corner. So as I mentioned, we tried to understand how did the regulation of COVID impact the behavior of people, and specifically because these regulations were specifically on like movement of people and so on. We try to understand what is the impact on the transition from physical to online shopping. And to understand the impacts of these regulations, we chose two countries with very different lockdown strategies, which are Italy, where I'm originally from, and Sweden, where the research is sort of located. And to do that, we conducted an empirical data collection in the form of a survey. This survey was spread online in the spring 2020, and we achieved 530 answers between these two countries, Sweden and Italy. And these answers were analyzed by statistical methods, such as descriptive analysis and multinomial logic models. And here I just want to highlight one example of results from the analysis. Of course, we see that there are differences in policies, but there are also differences in culture and, for example, readiness to the technology. And in Italy, we really saw that respondents were more likely to buy more work-related items because in Italy, people were not ready to work from home and were less ready compared to Sweden. So what we tried to sort of highlight here is that differences in policies, culture, and readiness combined to the individual needs. And here we mean that different, for example, households would have different individual needs and also different perspectives on what is essential, what types of shopping is essential. So this makes it so that we need to have diverse policy strategies that really don't exclude vulnerable groups in society. And of course, the COVID case was studied because we were in COVID when I started my PhD. But then after studying this case, I then moved on to a little bit more what I kind of wanted to do within the PhD, which is trying to study uh, how can we measure sustainability within urban logistics and what different concepts are out there. So first, I tried to build a framework, and this framework is composed by measurable indicators in the context of city that are sort of relevant in the context of city logistics and that enable us to understand different stakeholders' perspective. And after building this indicator framework, I then used the framework to study the sustainability impacts of different concepts that I listed here. And I also tried to find if there were challenges to implementation, for example, and how could we identify them using a framework. And in terms of methodology, I started from the Sustainable Development Goals. So this was done to sort of ensure the holistic perspective within sustainability. And then, of course, I looked at the existing literature, and I did also some case study analysis within the project that I was working in Stockholm. So the results was first a set of indicators that you can see here. And here I highlighted both the societal perspective, but also the logistics service provider LSP perspective. And then what you can see here is how I then use this indicator to understand how each concept impact the indicator in what I call a semi-quantitative way. But these results are relatively complex, and what I wanted to just focus on today is that first, that the results confirm the focus on the environmental perspective. This can be seen by the fact that there is quite a lot of research on air pollution and how this concept can actually contribute to a better air quality, basically. But at the same time, there is not a lot of literature on, for example, here I have highlighted working conditions. It's still uncertain if these concepts are going to improve or worsen working conditions, but also land use and accessibility. So I really think that a more holistic perspective is needed, and we need to sort of consider a broader perspective on sustainability. So these results sort of highlight this need. And then I digged a little bit more deeply into the off-peak case, and here we actually took some data from an existing case study where we looked at how we can actually use these indicators set in a quantitative way. And then, of course, we ran into some problems because we cannot really share the data and so on. But we could kind of still try to understand the impacts of off-peak using the framework and using the indicator set. Then, as I mentioned when I was introducing the four cases, I then decided to focus on one of these concepts. And this concept was consolidation or city hubs. And I would like just first to explain briefly what I mean by city hubs. You can see here a picture of what I believe the system looks like today. So we have logistics service providers that deliver from a distribution hub, which is often located just outside the city center or just outside the city boundaries, and then they deliver to the final receivers. And there are many of these companies that do the same. And often the final receiver, the final delivery point is often similar or the same for different providers. So the idea of a city hub is then to consolidate or cross-consolidate the cargo from these different logistics service provider, and therefore increasing the efficiency of the system. But this type of concepts has been studied relatively often in the literature, and therefore it's already been tried, and often it doesn't really work. So what I tried to do within my research is what are the potential barriers to city hub adoption, and how to try to identify those barriers, and how can we try to understand what type of both policies, maybe from the public sector or strategies from the different stakeholders, how can they be used to overcome barriers. And I focused on the transition between these two systems to try to sort of identify these barriers and these potential policies and strategies that could help overcome them. And I considered the different stakeholders within this research. I considered firstly the hub operator, so the sort of the company that operates these city hubs, the logistics service providers, and also the final receivers, the receivers of the goods. And in terms of method here, I have used system dynamics modeling that I have briefly introduced before. But now I would like to sort of take a little bit of a step back and introduce the modeling process if to you that maybe are not really familiar with that. So when we apply system dynamics modeling, we start from identifying a problem. And this is very important that in system dynamics modeling, we pay a lot of attention of identifying the right problem and articulating it in a way that makes sense to the problem owner and the stakeholders within the system. Then we build a dynamic hypothesis. This means basically understanding the dynamics in the system. What are the relationships between the variables and what are the causalities, feedback, and delays, and so on. And this is, of course, an hypothesis of what we think the dynamics are. And then we often build a quantitative model. This is not necessary to build a quantitative model, but often it's good if we want to test the policies and so on. And exactly, the next step is then to test policies or strategies using the models and using different scenarios, for example. And this process is very often iterative. We go back to previous steps and we often, even like when we finish the analysis and we look at policies, we often realize that we should have focused on a different problem or we should have sort of phrased the problem in a different way. So we often go back to problem articulation. So going sort of back to the City Hub case, here I started with a first problem articulation. What decisions could support the adoption of city hubs? And then I built a first qualitative model. And after this qualitative model, I sort of went back to the problem articulation and I refined it, looking a little bit more at the perspective of the hub operator and the logistics service provider, trying to understand under what conditions are city hub economically sustainable, because I realized that one of the barriers was the economic barrier, of course, and then how can different strategies impact the adoption of hubs. And then after this iteration, I actually realized that the perspective of the receivers was kind of missing in these models. So then I went back to the problem articulation and analyzed what was what is the willingness to pay of receivers. And this led to building a third model, which focuses on the perspective of the hub operator and the receivers. And of course, such modeling, such models need both qualitative and quantitative data. So I used a mixed method approach to collect all of this data. This included various types of qualitative data collection, such as interviews, group model building, but also quantitative data collection within case studies, and using also the literature and some groups, some advisory expert groups. And the first result that I can highlight from this case is that we really identified relevant dynamics in the system. So using system dynamics modeling, we really are able to identify the dynamics within the system and how these dynamics can sort of contribute to the problem that we are seeing in our system, and how can we use the model to identify potential action to solve the problem. And here I just want to highlight the three different perspectives of the hub operator, where we look at, for example, hub revenue and how can, because the economical barrier was very important, for example. So how can we ensure that we have a revenue from the hub, but also the logistics service provider, they also need to have a gain, and the receivers, looking at what type of value added services we could potentially offer with this type of services. And now I would like to give a little bit in a nutshell what are the major quantitative insights. So the first is that city hubs are economically sustainable only if collaboration is achieved. And I think that collaboration in terms of sustainability, when we look at sustainability in different fields, it's something that is often highlighted. Um, and in this case, what we see is that it is required for the logistics service provider and the receivers of the goods to collaborate and share the costs of the hub. And in this way, it could be really like a win-win for all. And here in the graph, we can see that these are two different scenarios. And when we have a scenario where we don't have collaboration, we see that the costs for the logistics service provider uh, get higher and higher. So we can see that this is kind of not sustainable versus if we look at a collaborative scenario, then the costs are lower. Yeah, as it's shown in the lighter green curve. Um, and then because I wanted to try to understand, okay, but why cost is such a problem? So then I tried to look at what is the total system cost. Um, and the interesting thing is that there is always an increase in total system cost, whatever scenario we look at. So we are building a more efficient system, but because we're adding an extra stakeholder, which is the hub operator, we see that there is always an increase in total system cost, as it can be seen from the graph. And this means that it's difficult to achieve economic sustainability, and we need to identify additional benefits. One thing could be to think about how the public sector could contribute, for example, looking at different policies. And that's also what I try to do within the model. I try to apply an environmental zone, for example. But we saw that implementing an environmental zone is not expected to help city hub adoption. And I wanted to highlight this here because I think that it's crucial to try to understand what is the impact of different policies, and these type of modeling tools can actually help doing that. And then finally, we looked at the receivers, as I mentioned. And as the receivers, we mean the receivers that the businesses in the area that receive the goods. And because these receivers are very different, they also perceive different values. And one of the results of this model was also that if we can understand these values, the values of the final receivers, we can then apply what we call a value-based fee. So looking at the values, we can sort of adjust the fee to different receivers. And this is really the best strategy for the hub operators if they want to achieve economic sustainability. Yes, so this was a short, in a nutshell, the results of this work. And now moving on to the final case of electric trucks. So here we studied first the concept of road freight transport efficiency. And this was already a challenge in itself. And we saw that this was very complex. Different stakeholders define efficiency in a different way. And especially, we also realized that there are a lot of dynamics between different kinds of efficiencies. And considering these dynamics is really important when we try to understand the impact of the electrification. So the overall goal of this case was to understand the impact of electrification on efficiency. And this, of course, in the context of sustainability and the overall need of reducing emissions. And again, I have used a system dynamics modeling method. In this case, I don't want to go through all the steps, but we've only built one system dynamics model, and we dedicated a little bit more time into the verification and the validation of the model. So we also did not just before building the model, but also after having built the model, we also did validation interviews and tried to show the experts if the results make sense and if we have used statistical data that also makes sense. And this model is built within the Swedish context. So we used statistical data mostly from Sweden. And then what we then tried to do in this case was to identify what policies could we introduce in this system when we look at electrification, and how do these policies impact the system? So we explored four different policies. The first one is an incentive to purchase electric trucks, so given by the government. The second policy is an investment in technology maturity. And by this, we mean that basically the public sector could offer some incentives to different types of industries to speed up technology maturity. And then we could also have some kind of tax on diesel fuel, so some sort of carbon tax. And finally, because we identified as charging one of the potential barriers of this transition, so we then tried to devise a policy that would sort of make the infrastructure, the development of the infrastructure a little bit faster. So instead of looking at the current fleet to plan the infrastructure, we could embed in the model some kind of prognosis of how much truck fleet we are expecting in 4 or 5 years, so that we can build the infrastructure with a long-term sort of perspective. And again, here I will try to go through how these policies kind of change the results of the model really quickly. When we look at the share of electric trucks, the long-term planning for charging is the best policy in the short term. So if we look at the sort of first phase of adoption, while the price of diesel is the best in the long term. But then, because we were looking at transport efficiency, of course, transport efficiency was one of our sort of interesting outputs. So we see here that the price of diesel is the worst in terms of transport efficiency. It really produces a rebound effect that doesn't enable the fleet to be used efficiently. And maybe I can expand a little bit on that in the discussion if we have the time. And in terms of demand, we see that the price of diesel decreases the demand in the short term. This is also what influences the transport efficiency, while the electric truck purchase incentive increases the demand in the long term. And with this, I also want to highlight that understanding these feedback and these rebound effect, especially of cost and demand, is really important. And yes, as I just mentioned, one of the sort of broad conclusions from this case is that the demand rebound effect is essential to be considered, because implementing electric trucks really changes the cost dynamics in the system. And then there are different trade-offs when we look at efficiency. Of course, in one case, we want to reduce emissions, but we also need to understand what is the impact on transport efficiency and how can we make sure that the transport efficiency doesn't decrease. And then finally, we identified 2 phases of adoption. So by identifying these 2 phases of adoption, these models actually allowed us to devise what is the right time to implement these different policies and what is the right place to implement these different policies if we want to sort of use the right sort of leverage in the system. And finally, sort of again connected to these 2 phases of adoption, what we did was then to design a combination scenario where we have 2 policies implemented in the first phase of adoption and 2 policies implemented in the second phase of adoption. And this combination scenario allows us to both speed up adoption, but at the same time, this scenario doesn't hinder efficiency or cost structure too much. And with this, I wanted to sort of highlight that these type of modeling can be used to understand these concepts and policies, and to also look at what type of combination we can use and how can we use policies at the right time. So now in the discussion part here, I would like to sort of go back to the research question and see, did I manage to answer them? So related to the first question, I built this set of measurable indicators, and I can say that this really allows to consider sustainability performance. I can say that this was one of the hardest part of my work, to actually identify this sustainability and how can we assess it. But I believe that this is a good first step. And of course, we could include more stakeholders in the future as well. And in terms of modeling, system dynamics modeling was really the perfect tool to understand the dynamics of the system. And within my research, I built these four dynamics model that I try to sort of explain to you today, and a little bit of results as well. And these models can be adapted to other case studies by adjusting the input data. So these don't just sort of provide insights on the current cases, but they can also be adapted to other cases. And finally, I also wanted to highlight that during the electric truck case, I built an online interface. This is available to everyone. And this interface can be used by different stakeholders to really explore the impacts of different policies. And this can be done live using the model, basically. And then finally, if we look at the last question, well, broadly, I try to identify the impacts of these concepts and policies, and I try to summarize them for you today. And I think that as general conclusion, collaboration is a key aspect in the City Hub context, but I believe in general when we talk about sustainability. And then I think that it is really important to find the right time and place to implement policies, and system dynamics modeling. But in general, I think system thinking can help in finding this. Yes. So to conclude for today, I just want to highlight the main contributions of my work. First is that I try to have a holistic perspective on sustainability. And then I built these 4D system dynamics models that represent dynamics complexity of road freight transfer systems. And I studied the impacts of COVID, electric trucks, consolidation cargo bikes, and off-peak hour deliveries. Some of them a little bit more in detail, and some of them a little bit less detailed. And then I also try to identify what policies can impact both electric truck but also City Hub adoption, as I try to summarize to you today. And with that, I want to thank you for the attention. And if you want and are eager to something to read over Christmas, that's the QR code of my complete doctoral thesis. But yes, now I'm really open for questions. Thank you.
Thank you, Claudia. Very well presented. I think a lot of, I guess, thoughts comes to my mind here. But maybe we have somebody of the participants who want to share thoughts, ideas, or questions. In that case, I think the easiest way is just to unmute, or if you want to put a question in the chat, that's okay too. But
Yeah, I was having a look at the chat, but I think
it's mostly welcome.
yeah, no, exactly.
Yeah.
Hi, Claudia.
Yeah. Hi.
Lance Becker. I work for Federal Motor Carrier Safety Administration in the U.S.
Mhm.
First, I applaud your multidimensional approach, both from the four very different use cases, but
Mhm.
also from the economic standpoint and the operational standpoints and things. This is the right way to do research.
Thank
I really appreciate the systems viewpoint. In your models for cost and emissions,
you.
did you did you consider the cost of the electrical generation
Uh,
in your cost of the
mhm.
energy itself?
Um, no. You mean I'm guessing that we are
But
kind
there's a cost of the electrical generation both in money and
Mm.
in greenhouse gases
Yeah, yeah, yeah. Mm.
and so there's impact of just that generation by itself. And so it's just kind of my question is, was that considered in your research?
Yeah, I mean, now I understand also the question. Yeah. So, yeah, first of all, I want to say that when we did both models, both the City Hub case, but especially the electric truck adoption case,
Mhm.
in that model, we needed to make some kind of boundary, and the boundary was the transfer system. And of course, I think that it would be very interesting to kind of expand that. And I have some colleagues at the lab that are actually looking at the building a model that couples not just the transport and infrastructure system, but also the energy system to look at
Yeah,
what
yeah.
energy infrastructure we need and so on. What is included in our model is the cost that the transport provider needs to pay for energy. So that is
Mhm.
what the cost that
Okay.
is included. And the same is the emissions of the production of energy. So the one that would be needed uh, to run the electric trucks. And now that in Sweden is relative. So this model was made for Sweden. So that
Okay.
cost that CO those CO2 emission for electricity generation are really low, because in Sweden we have a very green energy grid.
Yeah.
Uh,
Okay.
but of course, if we were to implement a similar model into another place in the world, so then that would be very, very, very different,
Very
I would
different.
say.
Yeah. Right. Right. Again, in Sweden, I assume that freight movements are not as long as they may be in the United States.
Mm,
And I don't know in Sweden if there are hours service limitations
yeah,
and those types of things for the drivers.
yeah.
Uh, but the one of the challenges, at least in the U.S. for electrification, is one, infrastructure, and two, the period of time it takes to actually charge the batteries and the vehicle miles traveled on a charge. So those are very diametrically opposed to one another because the driver wants to be on the road driving, but they have to stop and charge their vehicle to get distance. And then the third piece of that is, at least in the US again, there's uh, the vehicle weight of
Yeah,
electric vehicles quite different and quite more, and it's more of a challenge
mm, yeah,
because the load that they're carrying has to be less. And so anyway, there's a lot of good research opportunities
Yeah.
in those areas, but
yeah.
I, and it's just kind of a little thought flow there on my part on how could we take some of the things that you've developed
Mm,
and bring them into the US market. So anyway, just kind of creates a lot of thought energy on my part.
yeah. I mean, I think that I could show, I was trying to see, because I have a lot of complementary slides, because I was reusing the slides that I've made previously for my defense.
Yeah.
But I just thought that I could show this. So this is a sort of a very simplified vision of the model that we built um, for the electric truck case. And we have also included variables that improve over time, such as that are connected to the maturity. So that's something that I sort of reacted on what you said now, that, for example, the vehicle weight, the battery weight, is those type of things are heavy, but we are expecting them to improve in the future. So these
Right.
improvements is sort of driven by technology maturity. And this is how we can really use the system dynamics modeling tool, because we can make technology maturity improve over time on some assumptions. And then we can see how that kind of improves also the results of the technology. And that's, of course, so that is why in the beginning also adoption is relatively slow, because of these sort of these problems that in the end they hinder efficiency of the system. And then in the end, adoption could be faster if we achieve a comparative situation to the diesel trucks of today. And in terms of, we've also considered, now I don't think that we can see them here in this because it's just too simplified, so to say, but we've also considered the track characteristics and the driving characteristics. So
Ah,
so
good.
in Sweden, in Europe in general, we can drive just only a certain amount of hours, and only and then we need to give breaks and so on. So we have also included all of those types
Good. Okay.
types of things. And then of course, this system dynamics model is an aggregate model. That's also the reason the the reason why we can do such broad analysis and sensitivity, and the reason why we can use the model because the runtime of the model is then really quick because the information is relatively aggregate. So of course the results of these model are very at an aggregate level. So we see like the average truck and not like a detailed truck moving in the system. I just wanted to sort of highlight that.
Oh, that's good. I'm sorry, I'm taking up too much people's time here. I'm very interested. Did you have a particular systems dynamic tool that you used?
Yeah, we've used so I mean I have used different tools throughout my years of research, but the one that I'm using currently is called Stella Architect, and it's just a software that allows to build system dynamics models. And that
Standard
software,
standard architect? Is that what you said?
Stella Architect. So I can type it in the chat.
Yeah, yeah. Okay.
I believe it's spelled like that. And it's
Stella. Okay.
it's no, I don't remember the developer, but it's one of the so I think that there are two main software for system dynamic. One is called Vensim, and it allows also to Vensim can be used with a free version if if one is involved in academia in some way. But Stella is more expensive. Yeah, one cannot, there is like a 1 month trial period, but it cannot be used. So for example, I also teach this subject, and in that case we use Vensim because then we can actually give the free licenses to students, and that's but Stella Architect allows to do interfaces, online interfaces,
Wow.
and that's the one that I also highlighted during my presentation today. Yeah, so something like that, so that you can actually show you can with a link, one can just share the whole model, and you can go online, and everyone could different stakeholders can just play with the model, which I think is sort of fantastic.
Yeah, that is cool. Okay,
So
and then one last question. Did you do any SysML or MBSE modeling in your research?
no, not really. Uh,
It's fine. It's fine. It doesn't lean itself that way, but I just wanted to ask.
Yeah,
yeah,
but I think it's an interesting question. How do you, I mean, how can you tie these together? I mean, you take
Yeah,
your more technically oriented system models and then bring them into the dynamic modeling.
exactly. Yeah,
Um,
yeah.
so
That's a really great question.
still some work to be done. Of course, some of the ambassador tools offer you, if you do executable activity models or behavior models, you can run models, but they're not, I would say they're probably not as dynamic as these dedicated tools like Stella
mm,
and Sim.
yeah,
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 very good. Well, Dr. Claudia, you did a
yeah.
great job.
Thank
Appreciate
you so
that.
much.
I know these moments are pivotal in your life, and you did a great job. And I'm very impressed. Thank you for presenting.
Thank you so much for all the questions. It was a very interesting discussion.
Anybody else would like to pitch in here? I was thinking one of the things that I always sort of comes to my mind is where do you stop when you do such dynamic models? I mean,
Yeah.
are there any good guidelines for, okay, here's where I draw my boundary of my model?
Yeah, I mean that is very, very hard, and that is where I think that's one of the hardest things, because when we build system dynamics model, we always say that the more thing the more endogenous variables, the more sort of endogenous behavior we can consider, the better, because then the model really can sort of we can really we don't have to rely on inputs. But then, of course, the more we make the model endogenous, the more the model grows,
Mm.
and the more it's complex to also understand and difficult to validate, of course, because that's a big part of it as well. So I think that that's why I believe that the problem articulation, the first step, is very important, because we can really start from there and understand who is the problem owner, who is it that we are targeting with our model, so that we don't we don't set the boundaries too wide. And then I think that another thing that I believe is really good to do with system dynamics is to start small and make small working models, and then sort of extend. And then what I did in my case was to kind of extend until I finished the time to for my PhD. But of course, that was because I was doing research. But then I think in other fields, what is the most important thing is, did we make a model that our stakeholders can use and can be used for gaining insights on the problem?
Yeah.
But that's a really difficult question, I think.
Yeah. I think you have a point there. Any model we do needs to be responding to the stakeholders, if you like, capability to read those models to help us. So, yeah.
But that's why I think that these type of interfaces is really helpful, because they can really use it, and it's very, very easy to use. It just requires maybe a 5 to 10 minutes sort of tutorial, maybe.
Yeah, fantastic. Anybody else who would like to pitch in here?
I, I think I just had a question, Claudia. Thank you for well, let me turn on the video.
Yeah.
I just had a question. My name is Cecil. So my question was on the roadways. You mentioned roadways and the impacts, but was there a big impact when it came to roadways for this electric truck kind of
Um,
model?
you mean like if we make more like if we expand the infrastructure in that sense, how does that impact trucks? Or
Yeah. So like when it comes to the road freight transport system, right? Like we'll uh like the fuel stations are already in certain areas. So you're trying to transform those into, I guess, more electrical stations where they can charge.
Mm.
But with that also, is there going to be like impact to roadways? Will there need to, I don't know, be a different kind of model for these charging stations?
Yeah,
Or
I
will they
mean,
just replace?
yeah, we didn't really look at, for example, we didn't really look at the geographical location, where should we place the infrastructure, or how should the infrastructure develop. What we try to do is just to include the infrastructure within the model, in a sense. So we basically said, for the current fleet, we need this amount of charging infrastructure, and that is done using basically like some equation that tells us, to charge one truck, this is the amount of energy we need, and then this is the amount of stations that we need. And what we also included in the model is that if there is not enough infrastructure, so then there is queuing in the system. So this basically is a delay in the system, and that's of course impacts the efficiency of the system. Um, but we didn't, and we considered only stationary charging. And of course, this is a little bit of a limitation of our model as well. But I can say that in Europe and in Sweden, we can see that that is the way that the policymakers are seeing would be the best, the sort of the future of charging would be stationary charging. Of course, I think that we shouldn't lock in into just one solution, but that is what we did in our model anyways, to consider on this type of charging. And we didn't consider, as I mentioned, what is the impact of, for example, infrastructure placement, if the charging stations are placed in which part of the system. So that part we didn't really consider in our model.
Okay. Thank you.
Yeah,
Thank you for
thanks
the
for the question.
presentation.
Yeah, and actually, I think we here at our company has done some work on actually modeling construction sites and also terminals, because I think that's where you, like Cecil, comes in. There's also if you introduce electric charging and all that, it also impacts on the infrastructure, and there will be other ways to move around, other driving sequences, and so on. So yeah, so but again, you probably, as we talked about before, you need to cut somewhere in your model. So
Yeah, exactly.
all
Exactly.
right. Thank you so much, Claudia, for a very fascinating presentation here. And I'm really happy about your PhD. So
Thank you.
good. So with that, I think we conclude for today. We've done the question and answers. We'll see if we do another webinar in January. Otherwise, we'll be back in late February. And in between, we have this international workshop in Spain. So there will be focus on things like energy transition, smart cities, etc. So stay in tune for that and join. So for that, thanks for today. And so I wish everybody a very Merry Christmas. It's that time of the year. Or happy holidays, I should say. Some celebrate Christmas or something else. But anyway, most of us are having some kind of holidays coming up. So enjoy that, and we see you all soon again. So thank you.
Thank you so much.
And